Yes, sir. You may please start, sir.
So, hi, hello everyone. Shriram, Vignesh, Bhavna, Ashrita. So,
Good
yesterday
evening.
before leaving, hi, good evening. Great. We'll start today's session. So, yesterday before leaving, we were discussing uh, about this question. You had been given x raised to x raised to x. Right. So, how would we differentiate such a thing? What would we apply? Anyone? What can we apply in this case? So, obviously,
Log.
we will apply, yes, we will take the logarithm. Absolutely correct. So the natural log of y, so this x raised to x can be treated as 1 unit because it is in the power. So it will come out in the front. It will become something like this. Is this correct, everyone? Right?
Yes, sir.
Okay. So after that, you have got like two methods of solving it. What you can do is either you can treat x raised to x as one separate function and operate on it. So basically, you can treat this thing as product of two functions in order to differentiate. That could be your first step. Or one more step that you can take is that you can take logarithm one more time. So let us try the second case. See, the first case is that take x raised to x as one function and ln x as one function. Okay. So what will happen? This thing will become product of two functions. So you can differentiate x raised to x and then find its derivative. Another method would be to take logarithm of this equation. So if I take logarithm of this equation, it will become ln of y is equal to. So these two functions are in multiplied. So first I will take the logarithm of the first function. So it will be x into ln of x plus ln of x. Is this right, everyone? What I have taken is I have just taken the logarithm of both of these functions. I have got two functions and multiplied. So my logarithm basically adds both of these. And in the first, I had x raised to x. So this x came out in front. So it became something like this. Now I ask you to differentiate this thing. Fine. So differentiate this equation with respect to x. It is really simple. All you need to do is that apply chain rule two times. Can you do it, everyone?
Yes, sir.
Okay. So let us start then. So let us start from the right hand side first. So you have got x into ln x. How will you differentiate x into ln x? Derivative of x into ln of x. What will you do? Just tell fast. Vignesh, how will you differentiate x into ln of x?
Taking x as it is and differentiating ln x plus
Great.
differentiating x.
So product of functions, right? Product of two functions.
Yes, sir.
Okay. So x into a derivative of ln x is 1 by x plus. Now you differentiate x, you get 1 into ln x. Fine. Great. Plus you have got ln of ln x. ln of ln x. Which function is inside which function?
ln x is inserted in the ln x.
Great. Right? ln of ln x. So you approach from outermost side. The first function that you get is ln x. You differentiate it. You get 1 by x. What will be the first term that I write over here?
1 by ln x.
By Linux.
Great. 1 by ln x. I complete this level. I moved inside. I met ln x. What will be the next term that comes over here?
1 by x.
Great. 1 by x. So my right hand side has been completed. Now I move to the left hand side. Left hand side looks a little bit tougher, but is not actually. So you have got ln of y. So you have got ln of y. So over here, which function has been inserted inside which function?
ln of y is inserted in ln of x.
ln of x.
Great work. Right? So you approach from outermost side. The first function that you get is ln x. You differentiate it, you get 1 by x. What will be the first term that I write over here?
1 by ln
1
y.
by ln y.
1 by
Great.
LNY.
Great. So you complete this level, you moved inside, you met ln y. Is ln y, do I need to create a flow chart of ln y, or is this in itself, like, is this a composite function or not?
Yes,
Is
sir.
ln of y?
Y
This
is
is a
inserted
composite
into
function.
ln x, sir.
Great, great. Y has been inserted inside ln x. So I approach from outermost side, I meet ln x, I differentiate it. What will be the next term that comes over here?
1 by
1
y.
by y.
Great. I complete this level, moved inside, I met y. So, what will be the next term that comes over here?
1.
1, sir.
1.
No, sir. Y.
dy by dx.
dy by
Sir, dy by
dx.
dx. Yes, sir.
Which function are we differentiating with respect? We are
Y.
differentiating with respect to x, right?
Yes, sir.
So that is why it will be dy by dx. So now all I need to do is just equate my left hand side and right hand side. So I have got dy by dx divided by y times of ln y is equal to, so this thing, right? So it becomes 1 plus ln x plus 1 by x into ln x. Right? So I can just take it out this side. So my value of dy by dx basically becomes y into ln y into 1 plus ln x plus 1 by x into ln x. Fine. This is it. So I can just substitute back my value of y, right? Just substitute your value back of y and you'll get your answer. You can approach it by the other method also, but for that you will need to first evaluate what is the derivative of x raised to x. After that, you will be able to do it and you will get the same answer. So I hope all of you were able to do this question. Like it was really simple, right? Everyone?
So
Any issues in this? Yes, Vignesh.
RHS I can do, sir, but in the LHS I have a doubt. I mean,
Yes,
when I
yes.
did.
Okay, ask.
So I've clarified now, sir. When I was trying
Uh,
to make it solve,
hmm. Okay. So you were
I get
getting an issue?
yeah, sir, in LHS, sir.
Okay, okay, fine. So I hope it is done now. I hope it is clear now.
Yeah, sir.
Okay, great. Great then. So we have learned about logarithmic differentiation. So basically, what logarithmic differentiation does is, till now, as we have done that, you can take sum or product, sum or difference of two functions. Same way we have seen how to do if you have product of two functions, division of two functions, or you have one function inserted inside another function. And now using logarithmic differentiation, it has also given me the power to evaluate if one function has been raised to the power of another function. So overall, if you see any function that is describable using all of these operations. Do you all agree? There is no other operation possible by which a function can be described. So either two functions can be added or subtracted, they can be multiplied, okay, or divided. One function can be inserted inside another function, or one function can be raised to the power of another function. Fine. So that's all that you have got in chain rule. So over here, your chain rule ends. Okay. So this is all that you will ever need your chain rule for. No other possibility is there. Fine. So just for revision. So till now, like plus minus was really simple. We learned about product, then we learned about uh, division rule, then chain rule helped me in doing this, and then now logarithmic rule is helping me with this. So now let us try a few case wherein we are mixing up implicit functions and logarithmic functions. Logarithmic differentiation along with implicit functions. So first of all, can anyone just tell me what is meant by the word implicit function? We have done it just two classes before. What is meant by the word implicit function? Anyone? Implicit function. X and Y being represented in implicit terms. What does that mean? Anyone? Vignesh, Bhavna, Gayatri, Ashrita, Omkar, Shriram.
So I mean, it could have defined to solve.
Uh, See, we have done implicit functions, right? I hope all of you remember implicit functions. So everyone forgot implicit functions. You've just done it. So implicit functions basically, I'll just revise it to you. So
X and
implicit basically,
Y are separated, sir.
yes, yes, correct. X and Y are not separated. right? So for example, like we had done such a case, like you have got x sine x is equal to y sine like y x square plus something like this, something like this. So over here, y and x can't be separated out, right? Or okay, let us just take it 2y square, something like this. So over here, x and y can't be separated out, right? Like you can't write this thing in this form. Can you? You won't be able to write this thing in this form. Or you can make something even more complex, right? That is not possible. Not possible at all. So this is called implicit function, where x and y cannot be separated on each side. Okay. We have just done the derivative. I hope all of you remember. Just 2 classes back, we have done the derivative of implicit functions. Everyone remembers? Gayatri, Ashrita, Bhavna, Vignesh. Don't remember. How will
Yes,
you
sir.
find dy by dx in this equation that's been given to you? You have been given this equation x sin x is equal to yx square plus 2y square. How will you find dy by dx? Tell me. Anyone? Tell me. No
Derivative.
one. How will you take derivative? Like, how will you take the derivative of y into x square? How will you do that? How will you find the differentiation of y multiplied by x square? What will you do? Forgot?
Differentiate respective to x on the both sides
X.
and
So
take.
you can do on the left side, right? You can do on the
Yes,
left
sir.
side, right? Now tell me, how will you differentiate this thing? How will you differentiate y into x square with respect to x? How will you do that? Y into x square.
Product of two functions.
Great. Product of two functions. So tell me, what will be the derivative of y into x square?
2x into y plus
Plus
Hmm.
dy by
dy
dx
by dx into x
into
square.
Yeah. So, like, why did you forget implicit functions? We had just discussed 2 classes back. Fine. What about 2y square? How will you differentiate 2y square? Which function is inside which function? Okay, so let us just remove this 2 also for the time being. 2 is just a constant, it can come outside. So y square. You need to differentiate y square with respect to x. Which function is inserted inside which function?
Y
Y
is
is
inserted
inside
into
X.
x square.
inside x square.
X square, sir.
So you approach from outermost side, you met x square, you differentiate it, you get 2x. So what will be the first term that I write over here?
2y.
2y
2y
And
in
what about the next term?
d dy
dy
by
dy by dx, sir.
Yeah. So, okay, great. So I hope now all of you get what is meant by the word implicit function, right? Get it, everyone?
Yes, sir.
Okay, fine. Like, I don't know why you keep. Uh, okay, fine. So I would tell you that whenever you have any doubt, you can ask. Okay. Implicit functions we had just discussed 2 days back only. Fine. So from here, you have got a term of dy by dx. Fine. You have got a term of dy by dx. So you can just take out this term common and separate out the other terms. And you can find out what is the value of dy by dx. Fine. So let us just apply logarithmic differentiation and mix it with this thing. So you have been given y raised to x plus x raised to y plus x raised to x is equal to some constant c, some constant, any constant. So, and it is asking you what is the value of dy by dx or find dy by dx, the expression for dy by dx. Let us see how we can do it. So obviously my first thing that I would be doing is differentiating this whole thing with respect to x. Can you tell me what will be my RHS? If I differentiate this whole thing with respect to x, what will be my RHS?
0.
Yeah, obviously constant, right? Everyone, derivative of constant.
Yes, sir.
Okay, great. Now let us see, we have been given three terms on the left hand side. So we need to differentiate these three terms individually, right? And add, right, everyone? So let
Yes,
us
sir.
just take the first term. So I'll name these terms as A, B, and C. Okay. The first term as A, second as B, and third as C. So my first term A is equal to y raised to x. I need to differentiate this term with respect to x. How will I do it? Tell me. Y raised to x. How will I differentiate raised to x with respect
Applying
to
like
x? Okay. So I get ln of A is equal to x into ln of y, right? Is this correct?
yes, sir.
Great. After that, you take derivative with respect to
Differentiation.
x on both sides. Yeah, with respect to x. So you'll get 1 by a into dA by dx, right?
Yes, sir.
Correct? So how to differentiate this thing? Tell me. How will you differentiate x into ln of y?
Product, sir. Product rule.
Great. Product. Tell me the differentiation directly. Tell me the value of derivative directly.
ln of y plus
X into, tell me. X into, now you need to differentiate ln of y. How will you differentiate
by
ln of
One by
y?
y, sir. One by y.
by
1 by y.
x.
d by
1
dy
dx.
by dx.
by dx.
Yes, sir.
dy by dx.
Yeah, dy by dx. Great. So basically, I am asked to basically find the value of dA by dx. So I can just take a this side. So my value of a is y raised to x. So it becomes y raised to x into ln y plus x by y into dy by dx. Right, everyone? Is this correct? Right?
Yes, sir.
This is correct, right? Right. I just substituted back my value of a. Great. So now I'll do my second term. My second term that's been given to me is x raised to y. And again, like obviously, I'll go for logarithmic differentiation. So I'll take logarithm. So it becomes y into ln of x. This one is a little bit easier. So tell me, what will be the left hand side if I differentiate it with respect to x?
One by
What will be my left?
one by b into db by dx.
by dx.
Great. What about my right hand side? What will it be? Product of two functions, right?
Yes,
ln
sir.
ln x plus
Tell me.
1 by
No,
ln
no, it is. It will not be ln x. Think again. It is y into ln x.
yes, sir.
y,
Hmm.
sir.
Y into 1 by x plus
Great. Y into 1 by x. Great. Plus. Now you differentiate the other function. What will it be?
dy
Tell me.
by x into ln of x.
Great. Correct. Now it is correct? Yes, now it is correct. So my value of dv by dx will be, I'll just take this b this side. So it will be x raised to y into y by x plus dy by dx into ln x. Right? Right?
Yes, sir.
Great. Now we will approach on the third term. So the third term that's been given to me is x raised to x. I already know what is the derivative of x raised to x, but still I'll do it. Anyone remembers yesterday's class, so they can tell me what is the derivative of x raised to x? Okay, no worries. We'll do it again.
so y into
Okay, so you
ln x
sir,
power
x raised to x into 1 plus ln x, sir.
plus ln x,
yeah,
sir.
I've written it already, right? So yeah, great. X raised to x into 1 plus ln. That's correct. So obviously we will take ln of c. We'll get x into ln of x, right? Then I'll take derivative with respect to x, right? So I'll get 1 by c into dc by dx, right? Can you tell me what will be the derivative of the right hand side? X into ln x. What will it be? The derivative of x into ln x.
1 plus
1 plus
Hmm.
by keeping
Tell me 1 plus
x, ln of x,
how much? Yeah.
ln of x.
Yeah. Because see, when you differentiate ln x, you will get 1 by x, right? So x into 1 by x. So that becomes 1. And then after that, you differentiate x, so you'll get 1. So 1 into ln x. So 1 plus ln x. So obviously, your value of dc by dx is this thing. So just going back to the top, what do we have over here?
sum of the three
We have got
derivations.
is equal to constant, right? Right. So you have got a plus b plus c, okay, terms is equal to some constant c. And now I am asking you to differentiate. So what will happen? dA by dx plus dB by dx plus dC by dx will be equal to how much?
0, sir.
0.
Great. Zero. Zero, right? So what I will do next, I have already calculated my values of dA by dx, dB by dx, and dC by dx. I'll just substitute it over here, right? So I have got y raised to x into, it is a really long problem. Like it is one of the typical questions that comes for 5 marks in your board exams. Okay. So in your board exams, you'll generally get some question like this. Plus, okay, dB by dx. So it becomes x raised to y into y by x plus dy by dx into ln x plus x raised to x into 1 plus x is equal to 0. So basically, what is it asking you? It's asking you to find the value of dy by dx. Fine. It is asking you to find the value of dy by dx. So how would you do it? The value of dy by dx. See, we have already got the terms of dy by dx. We just need to separate it. Fine.
Yes.
We just need to separate it. So it's like the question is already done. The remaining part is just calculation that's left. The remaining part that's just left is a little bit of calculation. So you can just open up these and take the terms of dy by dx common, and I'll just give you the final answer so that we can just go ahead with. Okay. So you can do is you open these brackets, apply distributive property. Okay. And after applying this distributive property, you take out the terms that have dy by dx in common. After that, you replace all the other terms on right hand side, and then just you get this answer. So instead of doing repetitive questions, it was better to skip that one and move on. Fine. So just one or two more questions related to this thing. So you have got x raised to y plus y raised to x is equal to 1. Now it is asking you to find the value of dy by dx. Let us see how we can do it. So obviously, you treat your first term as a, your second term as b, and a plus b is 1. I
Yes.
differentiate it with respect to x, right? Okay. So you'll
Yes.
get dA by dx plus dB by dx is how much? Tell me. How much? Anyone? If I differentiate this whole equation with respect to x,
Raised
what
to
will be
1.
my value of d?
Yes, sir.
1. 1.
X
Zero, sir.
0, sir.
0,
0,
right?
sir.
Derivative of 1 is 0, right?
Yes,
So
sir.
now basically it is asking me to find the value of dy by dx. Even though I can do it again, like x raised to y, take logarithm, apply chain rule, but I have done it, so I'll copy it. X raised to y, I have already done it, so I'll just copy it. So I've got x raised to y into how much? Y by x plus dy by dx into ln x. So I've got x raised to y into y by x plus dy by dx into ln. Fine. I have just copied it from the question. Again, like I have got b also as y raised to x. So I can copy the derivative of that also. Great. So I already have calculated in the previous question, so I'll just copy it from there. So y raised to x into ln y plus x by y into dy by dx. Ln y plus x by y. Right, everyone? So I just copied these two from the questions in the top. So what will I do next? Tell me. What should I do next? I have the value of dA by dx. I have the value of dB by dx. I'll just substitute it in this equation. dA by dx plus dB by dx is equal to 0. So I'll get, just copy it inside. So you'll get y into x raised to y divided by x plus dy by dx into ln x into x raised to y. So I'll just write for the time being my dy by dx as y dash in order to easily solve it, plus x raised to y, y raised to x into ln y plus y dash into x into y raised to x by y. This thing, how, tell me, how much will this thing be equal to? The sum of these two, how much will it be equal to?
0.
Great. 0, right? It will be equal to 0, correct. What will I do next? I need to calculate my value of y dash. Okay, that is what I am looking for, my value of y dash. So obviously I'll go for it. So y dash into, I'll take out the terms common. So I've got ln x plus, ln x into x raised to y. Okay, plus x into y raised to x minus 1. Okay, then I've got these two terms that are added plus. So I have got y into x raised to y minus 1. Okay, and over here I have got y raised to x into ln of y. This thing is equal to 0. Can I calculate my value of dy by dx now? Everyone, can I calculate dy by dx now? Tell me.
Yes, sir.
How should I do it?
Y dash is equal to
Minus
uh,
y raised to x into ln y plus y into
Minus
x.
of this thing, right?
yes,
Right,
sir.
sir?
Divided by ln x into x raised to
This
y
thing.
plus into y raised to x minus 1.
Great. Right? This is correct. So this is my final answer.
Yes, sir.
Okay, correct. This is my final answer. And what if I give you a specific value of x? If I tell you that I am giving you a specific value of x, let us assume it to be some value 1. What will you do next? What will you do after that?
Putting the value of 1 in x.
X
Sub-
is a
Great.
value of
Yeah,
like
correct, correct, correct. And what if you require the value of y also? What if you require the value of y somewhere? What will you do? If you need the value of y, like over here, you have got terms of y also and x also. So x I am already giving you some constant c. What will you do if I like you will need some value of y also? How will you get that value of y? So you will use your original equation, right? The equation that was given to you. You have been given this equation. In this equation, you will substitute your x as the value that was given to you, and you will get your value of y. This is how
yes,
it works, right? Okay, so keep revising. Don't forget it. I hope all of you have understood. Any doubt in this question, anyone? Just ask me if you have any doubt in this question. Any doubt, anyone? See, what we have done is you have got x raised to y plus y raised to x is equal to 1. and it was asking you the value of dy by dx. So what we have done is we took our first term as a, second term as b, and a plus b is equal to 1. Okay. So obviously I differentiated this whole equation with respect to x. So I got dA by dx plus dB by dx is equal to 0. Okay. So my a is equal to x raised to y. I differentiated a with respect to x. Okay. Applying logarithmic differentiation. We have just done it in the top. X raised to y. We have just applied logarithmic differentiation and calculated the value of dA by dx. Okay. Similarly, the same goes for dB by dx also, y raised to x. I've calculated. So I just put it back in this equation. Okay. And I took out the common terms to both dy by dx. The terms that were common to dy by dx, I took it out as common. After that, I solved it and I got this. Anyone, any doubt in this question?
No,
No.
sir.
Fine. Sriram, Amani,
No doubt, sir.
Ashrita, Vignesh, understood? Okay.
No doubt,
Understood?
sir.
Okay, great.
Yes, sir.
Let us see how we can do this one. So you have been given cos x raised to the power of y is equal to cos of y raised to the power of x. So cos x raised to y is equal to cos y raised to x. Now it is asking you, obviously, it will ask you the same thing only again and again. It will ask you dy by dx. So tell me, what should we do? What should we do in this one?
For applying log on both sides.
Okay, great. So tell me, if I apply log on both sides, what will be the terms that I'll get?
Y into ln of cos x is equal to x into ln of cos y.
Great work. And after that, what will be my next step? Tell me. What will be my next step?
Product.
Differentiation.
Okay, differentiate with respect to x, right?
Yes, sir.
Right? Great. Correct. Absolutely correct. So tell me, should we do the left one first or the right one first? Okay, let us do the left one first. Tell me, how will you differentiate this thing? Y into ln of cos x. How will you differentiate y into ln of cos x?
Product rules, sir.
Product rule, sir.
Tell me the derivative directly. Tell me the derivative directly. Dy by dx into ln of cos x, right?
Yes, sir.
Plus
Yes, sir.
y into
1 by
1 by
cos
cos x
2 sin minus sin.
into
Into minus sin
minus
x.
sin x.
minus n. It's correct. Absolutely correct. So I can just take this thing common and write it as minus of tan x. Do you agree? Minus of tan x,
Yes, sir.
right? Right? Minus of tan x. So I'll just write, like, in order to ease it, I'll just write it like this, minus of tan x. So yeah, your left hand side is absolutely correct. 1 by cos x into minus of sin x we got. So I wrote it as minus tan x. Great. After that, you have got the right hand side also. Tell me, what will be the derivative? How will you take the derivative of this thing? How will you take derivative of this thing?
1 into
1 into ln of cos y.
Y.
Okay, great. This one was really simple. Now the tough part starts. X into. How will you differentiate ln of cos y?
1 by cos y into
Minus sin y into dy by dx.
Great, great, absolutely great. So that too without drawing the flowchart you are able to do now. Okay, so Great. So from now onwards, I guess we won't need this flowchart thing, right? You are enough to do it on your mind, right? So again,
Yes.
I'll write this minus sine y by cos y as minus tan y. I'll write it as minus of tan y, right? So what should I do next? I should equate my LHS and RHS. I'll equate my LHS and RHS. So I'll write it as y dash just for the sake of easy writing. Ln of cos x minus y of tan x is equal to ln of cos y minus x tan y into y dash. So I'll just take it y dash this side. So y dash into ln of cos x, okay, plus x into tan y is equal to ln of cos y plus y of tan x. So my value of y dash or dy by dx is basically what?
ln of cos y plus y tan x by ln cos x plus tan y.
Great. So this thing divided by this thing, right? Right? This is correct. This is
Yes,
correct, everyone?
yes, sir.
Okay, great. Great, correct. Okay, so we have successfully completed logarithmic differentiation and implicit differentiation. And now we have also like completed of how if both of them are mixed. So I would just give you one question as homework related to these. So the question, like it is really simple. It is telling you that y raised to x is equal to x raised to y. Okay. So find dy by dx. Can you just tell me fast, how will you approach this question? Like, what will be your approach to the question?
Applying
Just tell
law of
that to me.
Sir,
dy by
apply
dx.
Okay.
both
Apply.
sides.
So
Differentiating
basically,
with
you
respect
will
to
Inserting.
x, right? You will differentiate both your sides with respect to x, right?
Yes, sir.
Yes, sir.
Okay, correct, absolutely correct. And after that, you'll get some terms of dy by dx. Take that as common, and that will be your answer. So just one more, like you can take one more similar question. So you have been given x into y is equal to e raised to x minus y. It is an implicit function also, but you won't actually require logarithm if you just think a little bit. You won't actually require logarithm in this one. You can do it by logarithm if you wish to, but if you just think it is e raised to x minus y, e raised to x minus y can be solved without taking logarithm also. Fine. So I want you to do this second question without using logarithm. Fine. Okay.
Okay, sir.
Will you be able to do it without using logarithm?
Yes, sir.
Yes,
Right?
sir.
Because you have got e raised to x minus y, so you can just directly apply chain rule. Fine. Great. So now we are moving ahead with parametric substitution. So basically, what is meant by this parametric? So first, let us just discuss what is meant by a function in a parametric form. I hope you have done this parametric form when you were doing conic sections. So for example, what happens is you have been given this equation. Fine. You have been given this equation. X square plus y square is equal to 1. So any point that lies on this curve, any point x comma y that lies on this curve can be represented using just one single variable theta. How can it be represented? If I take x to be equal to cos theta, okay, if I take x to be equal to cos theta and y to be equal to sine theta, right? So what will happen? I can just represent x square plus y square is equal to 1 using just one variable theta. And this theta will be my parameter. So do you all agree that I have converted my equation from this x and y to variable theta? So this theta can be called my parameter. Similarly, if you have an equation like this, x square by a square minus y square by b square is equal to 1. So you can just take your x is equal to a times of secant theta and y to be b times of tan theta. Have you done this during conic sections, everyone? Conic sections? Do you remember doing this, such a substitution? Anyone?
Yes,
Is the
sir.
conic sections chapter completed first of all? Conic sections, is it completed or not completed? First, just tell me that. Just tell me, is it completed or not completed?
Yes, sir.
Okay, it has been completed. Okay. So basically what is happening is that I am representing my function, my variables x and y in terms of a third parameter theta. Okay. And now if I ask you to find the value of dy by dx, okay. If I find you to differentiate, if I ask you to differentiate y with respect to x, what will you do? Because what the issue is, I know y in terms of a parameter theta, and I know x in terms of a parameter theta. How will I differentiate one function with respect to another function? Anyone remembers 2 classes back? How will I differentiate one function with respect to another function? See, I'll tell you what the issue is. The issue is I know y in terms of theta. Okay. I know y is equal to sine theta. And I also know x in terms of theta. I know x is equal to cos theta. But I don't know what is the relation between x and y. For the time being, forget this thing. You don't know this thing. Okay. For the time being, forget this relation. So currently you don't know what is the relation between y and x. Okay. You don't know what is that. But you know what is the relation between y and theta and the relation between x and theta. And now I am asking you to differentiate y with respect to x. What will you do? Anyone? How do you differentiate one function with respect to another function? Anyone? How do you differentiate one function with respect to another function? Anyone? We have just done it 2, 3 classes back. Anyone can tell me?
F dash of x by
Yes, correct.
dash
Absolutely.
of x.
So what I do is I divide my numerator and my denominator both with respect to that parameter. Okay. So I can write it as dy by d theta divide by dx by d theta. Right?
Yes, sir.
Is this correct, everyone? Chain rule. Just basic chain rule. Right? Can you tell me what will be dy by d theta? What will be the value of dy by d theta? What will it be? I know what is y is equal to y of theta, right? Y is a function of theta. So I can directly write it as y dash theta. Right, everyone? Do you agree with this or not?
Yeah, sir.
See,
Yes,
if
sir.
y is a function of x and I write dy by dx, so you can just directly write it as y dash x. The same goes for theta also. Right? So just in your thinking, just replace your x with theta and you'll get this. Can you tell
Yes,
me what will be my denominator?
X dash theta.
Yeah,
x
great.
dash theta.
Correct. So basically, what is it asking me? Like, what is it wanting me to do? So first of all, it is asking me that if you know y in terms of theta, you differentiate y with respect to theta, and you differentiate x with respect to theta, and you just divide both of them. You'll get your value of dy by dx. Fine. Let us just try it on the first curve, on the first parameters that I have got. So the first thing that I've got is y is sine theta. Okay, y is equal to sine theta, and x is equal to cos theta. Fine. So it is asking me to obviously find the value of dy by dx. So in order to do that, I already know my value of y of theta is sine theta. Okay, y of theta is sine theta, and x in terms of theta is cos theta. Can you tell me what will be my value of y dash of theta? Y dash
Cos
theta,
theta.
anyone? What will it be?
Cos theta,
Cos
sir.
theta, great. What will be my value of x dash of theta?
Minus sine theta.
Minus sine theta. So my value of dy by dx is basically y dash with respect to theta divided by x dash with
Minus
respect to
cot
theta.
theta.
So my, how much? Minus
Minus cot theta.
cot theta. Great. Minus of cot theta. Correct. So you'll get your answer. See, in this question, you were not given this thing. Okay. You didn't know this thing. And neither do you want this, want to know this. This is how you can write one equation in terms of just one single parameter. So I hope you have done such a thing while studying your conic sections. So if you have done this, so I want to ask you, how will you represent your ellipse? So you've got a ellipse like this. How will you represent your ellipse in parametric form? Anyone? Ellipse in parametric form. See, circle we have done, hyperbola we have done. Ellipse, how would you do it? No one remembers.
H plus
See, it is easy, like really easy. X is equal to a cos theta and y is equal to b
y
sin
equal to
theta,
b sine theta.
right? Why do you keep forgetting, everyone? Great. So let us do your parabola also. So you've got y square is equal to 4ax, something like this. Can you represent? Can you represent this thing? I mean, it is. You can do it, right? No, not in terms of theta, but you generally write it in t,
T is yes, sir.
right? So you take your y
X
as
equal to
280,
80, x equal to 80 square and y equal to a theta 2, 82.
right? 280. That is what you're trying to say.
Yeah,
280.
280.
Yeah. This is what you do, right? Everyone.
Yes, sir.
So, okay, great. Conic sections bhi bhul gaye. Great, then let us give it a try in this case also. So basically, like what we are doing is that now we are differentiating with respect to a parameter. Let us give it a try in this parabolic case. So you have been given your x as 80 square and you have been given your y as 280. Okay. And obviously it is asking you the value of dy by dx, dy by dx. So in order to do that, can you just tell me what is the value of dy by dt? The value of dy by dt. A is any constant.
0.
Uh, no. Your derivative of y with respect to t. Think again. A is constant. So you have got 280. What will it be?
Sir, is it 2a?
Yes, 2a, right? What is the derivative of t? The derivative of t is 1. So 2 into a into 1. So it is 2a. What about dx by dt? How much will it be? Tell me fast. Anyone? How will you differentiate?
It is
How much?
2a.
Yeah, 280. Why was it so confusing? Everyone, what is confusing you? Tell me. Like you just treat a as any constant and you need to differentiate it with respect to t. And now I'm asking you, what is the value of dy by dx? So what will you do? Dy by dt divided by dx by dt. That's it, right? So tell me, what will be the value? You'll get 2a divided by 280. Your final answer is 1 by t, right? 1 by t, everyone, right? Do you agree, everyone? 1 by t.
Yes, sir.
Great. So your x has been given to you as a into theta plus sine theta. Okay. and your y has been given to you as a into 1 minus cos theta. Again, dy by dx. Let us see how we can do it. Can you tell me what is the value of x dash of theta? The derivative of a is again any constant. So you have got x is equal to a into theta plus sine theta. What will be the derivative of x with respect to theta? A is any constant. So you need to differentiate theta plus sine theta with respect to theta. What will it be? Tell me. No one. What is the derivative of theta plus sine theta with respect to theta?
Sir, it is
Huh? Tell me.
1
plus cos theta.
Yes. Like just in your thinking, you can just replace your theta with x. So it is basically x plus sine x. I am asking you to differentiate x plus sine x with respect to x. Right? Just there is just a change in variable. Change in variable won't affect your answer, right? Why is it affecting your? Okay, now tell me. What about this one? Vignesh will tell me.
Sine theta, sir.
How much? Okay, great. Just sine theta. Think again. What about a?
Yeah, sir. A into sine theta.
So your value of dy by dx is basically y dash of theta by x dash of theta, right? So you'll write it as a sine theta divided by a into 1 plus cos theta, right? So a got cancelled. So you get sine theta divided by 1 plus cos theta. If you want, you can leave your answer like this also. Otherwise, if you want to do a little bit more trigonometry, you can do it this way also. Right? Style मारना है. ठीक है. So as you want, you can do it. This answer was also correct, and this answer was also correct. So fine, right? I hope all of you understood why how we got from this to this, right? Trigonometry. So I wrote sine in terms of half angle formula. So 2 sine theta by 2 into cos of theta by 2. And 1 plus cos theta can be written as 2 cos square theta by 2. So I just cut out the cos and I got this tan of theta by 2. Fine, everyone?
Yes,
Got it?
sir.
Okay. Great. Now what happens many times in questions is that we have been given an equation, but the equation is very tough to differentiate. So we need to convert that to its parametric form. So let us see an example in this case. Okay. Parametric substitution can be done from your side also. It is not necessary that the parameter will be given to you. Sometimes you can be given an equation. So for example, I give you an equation x raised to 2 by 3 plus y raised to 2 by 3 is equal to a raised to 2 by 3. A is again any constant. Fine. A is any constant. And now I am asking you to find your value of dy by dx. So obviously, if you try to differentiate this equation, let us see how it will work. So can you tell me, can you differentiate this whole thing with respect to x? Can you do it? Can you tell me what is the derivative of the first term with respect to x? What will you get?
2 by
Tell
3
me. 2 by 3 into x raised to?
X plus
minus 1 by 3.
minus 1 by 3.
Great. Plus. Now you have got y raised to 2 by 3. How will you differentiate y raised to 2 by 3? Like inside x raised to 2 by 3, y has been
Chain.
put, right? So yeah, chain rule, basic chain rule. So you differentiate this thing, you get 2 by 3 into x raised to minus 1 by 3. So
Yes.
in place of that, what will be the first term that I write?
2 by 3
2
into
by
y
3 y raised to minus 1 by 3.
into dy by dx.
Great.
Yes.
What about my right hand side? A is any constant. So what will be the derivative of a raised to 2 by 3?
No, sir.
0, right? 0, everyone, because a is a constant, so a raised to 2 by 3 is also a constant.
Yes,
So
sir.
over here, I can cancel out my 2 by 3, 2 by 3. I'll get my value of dy by dx directly. So I'll get my value of dy by dx as minus x raised to minus 1 by 3 divided by y raised to minus 1. So it is basically minus y by x whole raised to 1 by 3. Right, everyone? Right?
Yes, sir.
Okay. Now, instead of doing it this way, okay, so this was the first case. And in this particular case, it was really simple because the function was easy. Now, I want you to be doing the same question in a different way, in which I create a parameter of this equation. So instead of writing the equation like this, I will be creating a parameter in order to substitute it over here. So let us see how it can be done. If I write my x as a into cos cube theta, okay, and I write my y as a into sine cube theta, right? A into cos cube theta and a into sine cube theta. Do you agree that it will still satisfy this equation? You can check it if you wish to. So x raised to 2 by 3 will be a raised to 2 by 3 into cos square theta, right? And y raised to 2 by 3 will be a raised to 2 by 3 into sine square theta. So when you add both of these, your cos square theta plus sine square theta will make it 1. So what will be your final term? Tell me. Right? Will it be equal to a raised to 2 by 3?
Yes, sir.
Right? So you agree that this parametric substitution is an accurate representation of this curve, of this equation that's been given to you. So now I want you to approach this question using parametrics. Let us see how we can do it. So this would be the last question for today. Fine. So just look at it. Can you tell me what will be the value of x dash of theta? How will you differentiate a into cos cube theta? A into cos cube theta. You have got cos cube theta. Which function is inside which function? You have got cos cube theta.
X cube is cos theta is inserted in the x cube.
Okay, or like you can call it theta cube now because you are differentiating with respect to theta, right? I'm asking you to differentiate with respect to theta, so now everything will be in terms of theta. So I differentiated with respect to theta, I get 3 theta square.
Theta square.
What will be the first term? First term that I write over here.
3 cos
Great.
square theta. Into minus sine theta.
Into minus sine theta, right?
Yes, sir.
Fine. Now I want you to tell me what will be the derivative of this thing. My right y also. Can you differentiate the y also for me and tell me?
Yes, sir.
First, just a minute. This theta should be over there. Yes, tell me. What will it be?
A raised to
Derivative of
2
y. So
by
you have got sine cube theta. Tell me. Okay, just
a
a
to
minute.
3 by 3 sine square theta into cos theta.
How much? 3? Tell me.
Sine, 3
Sine
sine
square
square.
theta into cos theta.
Great, correct. So since I was calculating the value of dy by dx, it will be equal to y dash theta divided by x dash theta, right? We have just proved it. So I'll just divide these two things. My a and a will get cancelled. And the remaining term I'll get as 3 sine square theta into cos theta divided by 3 cos square theta into minus of sine theta. So again, 3 will get cancelled. I'll get my final term as minus of tan theta. Do you agree? Minus of tan theta. Right? So I'll get my value of minus of tan theta. So if you look into the definition of these parameters again, if you look into the definition of these parameters, just a minute. I'll erase this part over here. And you divide y by x. Okay. If you divide y by x, what is your y by x? Do you agree it is tan cube theta? Y by x, right? Sine cube theta by cos cube theta is. So I can write my tan theta as y by x raised to 1 by 3. So your minus of tan theta will be minus of y by x raised to 1 by 3. So using your parametric substitution and using your normal method, you have got the same answer. Since this was a really easy equation, it was easier to apply differentiation like normally differentiation using chain rule. But in the questions that we will be discussing tomorrow, it will be a lot more tougher to do it in the normal way. Fine. So you will need to imagine or create parameters of the equation that's being given to you. Fine. So that's it for today. Thank you. Sir, can you please end the class?
All right, sir.
Thank you. Thanks.
Thank you, sir. Students, please join the next session.